Plus, it's Thursday. We're going to have less time. I don't want you to have a whole lot to do at home. So let's just all stay together so we can get through this as quickly and efficiently as possible. So,
Jinx, you owe me a Coke. Sorry.
okay, that's not being efficient. So, graphing lines. Yesterday, we had to take each x value, plug it in, work it out, get the y value, take the point, put it on there, make the line. A lot of work. Okay, it's a lot of work.
Too much.
Here's the shortcut. This is a lot easier for us to do, but it's harder for us to kind of wrap our brains around at first. So, we're going to follow very, very simple steps, okay? We're going to identify m. Of course, that's our slope. And we're going to identify b. Now, we should be professionals at this already because of the worksheet we did on Tuesday. Yeah, Tuesday. And the Alex we did on Tuesday, right? Whatever's in front of x, that's my m. Whatever's being added or subtracted on the end, that's my b. Nice and easy. So step one should be simple. Step two is we're going to turn our slope into a fraction. Okay, we're going to turn our slope into a fraction. All right? If it's not already a fraction. How can I do that? Well, if I had m is equal to 2, how can I turn the number 2 into a fraction?
2 over 1.
2 over 1. Exactly, Alicio. We just put it over 1. So if your slope is a whole number, like 2, 3, -7, 1, turn it into a fraction by putting it over 1. All right? And this is why all year I've been saying, I hate decimals. I don't like decimals. Decimals are ugly. Because now we need our slope to be a fraction. So I wanted your brains to be used to seeing fractions and using fractions for this exact reason.
Fraction is kind of a weird word.
Okay, again, we're not being efficient. So we're going to turn m into a fraction if not already. Then we're just going to start graphing. No plugging in, no math, no solving, none of that. We're going to begin by plotting your b. Okay, begin with b. Whatever your b is, that's what you begin with. You guys get it, right?
Yeah.
We're going to plot our b on the y-axis. I'm angry?
No.
Oh, okay, let's focus on this then, guys.
Calm down.
Okay. We're going to plot our b on the y-axis. And that's just a point. So we're going to write in here as a point, of course. So if my b is 2, I'm going to find 2 on the y-axis, make a point. If my b is -6, I find -6 on the y-axis, and boom, make a point. Okay? From that point, we're going to rise, like we know how to do already. We're going to rise the number of spaces in your slopes. I'm going to highlight that in my slope color. In your slopes numerator. Where's the numerator on a fraction? On the top, right? So whatever number we have on top, in this case 2, we'd rise 2 spaces. Okay. What direction do we want to rise if my slope is positive again?
Up.
Up. What about if my slope is negative?
Down.
We're going to rise down. All right? Now, I would highlight this just so you don't forget, but not in a super dark color, probably not a purple or a green or a blue if possible. As long as you're able to read it and you know it, then that's fine, I guess, but
Blue on oxide.
it's all right. Can you still read it?
Yeah.
Okay, then you're fine. So we're going to rise the number of spaces in the numerator. Obviously, next we're going to, what do you guys think? After we rise, what do we do after we rise? We run. So we're going to run the number of spaces in our slope's denominator. Where's the denominator in my fraction? Fraction has a top and a bottom. Which one's my denominator? The bottom. Okay. I assume you guys are answering in your head. Hopefully we know the denominator's on the bottom. If not, we're in trouble. And of course, we always run to the what direction? Right.
Right.
Okay. Run right. R to the R. Run to the right. Never going to run to the left. Always run to the right. Okay?
But like, okay, never mind.
Now, I know these steps seem confusing. Once you see it in action, you'll be like, oh, that's super easy. So then you're going to draw your second point wherever you land and continue this pattern. Okay, so if we rise 3 and run 2, we'll rise 3 more, run 2 more, rise 3 more, run 2 more. And then we're going to reverse both directions. This is the only time we'll be running to the left, actually. We'll talk about step 7 once we actually get to it. So I know that process seems like a lot. Let's see what it actually looks like, because it's really not that much. Let's say we've got an equation like this. Y is equal to 3 over 4x plus 2. Who could help me out? What is my step 1? What did we just say my step 1 was going to be, Ray?
Identify M, the slope, and B, the y, as you said.
Okay, so with our highlighters, right, whatever color you used for slope, what's my slope in this equation?
3
over
over
4.
4.
3 over 4.
3/4.
So my M is equal to 3
4.
over 4.
B is 2.
And B is what?
2.
2. Good.
B times 1.
Okay, my B is 2.
Oh, I never got my in check.
Okay, sorry.
All good. Neighborhood.
What does step 2 say to do?
Turn M into a fraction if not already.
Perfect. Is M already a fraction?
Yep.
Yep, we can skip step 2. We don't have to worry about it. It is already a fraction.
What's step 3?
Step 3 says what?
Begin by plotting B on the y-axis.
Okay, good. We're going to begin at our B. Where's my B?
Your B is 2.
Okay,
Yeah.
so go ahead. Next to your 2, we're going to write begin. Right, that's what our B stands for. And then in whatever color, it doesn't matter, I want you to highlight your y-axis.
Oh.
Okay, so here's my y-axis. I'm going to highlight it.
Mysterious.
Because that's the line I'm looking for to plot my B. That's where I begin, right? So on this yellow highlighted line that I have, where is positive 2?
On the other side, on the left. No, on the right.
Right there.
On the left or the right? On this yellow line, is it
No,
up top or
no,
down
no,
below?
no, down.
It's up top, okay. We just find the number. I know it's kind of hard to see the numbers. But if there's my origin, we go up to positive 2. And we begin by making that first dot. Okay. No coordinates needed because we know that my B lands on this line. Every time. It intercepts the y-axis, okay? There's step 3. What does step 4 say to do?
Step 4 says, from that plot, rise the number of spaces in your M's numerator.
Okay, what's the numerator of my slope equal to? What's my slope's numerator, Angelina?
3.
3, right? Good. And Zach, you said it too. 3. So, are we going to rise 3 or are we going to run 3? What does the step say to do? We're going to rise first. We got to rise
Before you run.
before we run. Now, because I've got a 3 here, what direction am I going to be rising?
Up.
Up, because it's
Positive.
positive.
Oh,
Let's go.
Yep.
Sorry.
Rise because it's positive. Okay, guys, please stay with me. So from here, I'm going to rise 3 spaces up. 1, 2, 3. Okay? I'm just going to do a little line there just so I know where I'm rising.
And then you gotta plot 3 still. 3.
Okay, step 5 says now I'm going to run the number of spaces in my denominator. What number's in my denominator?
4.
4. So I'm going to run. What direction am I running?
Down.
To the right.
What?
We always run to the
Right.
right.
But it's a -4. Oh, no.
It's a positive
I saw
4.
the fraction board.
That's all right. Negative would be in front. But the denominator would never be negative because we're always running to the right. Okay? So I rose 3. I'm going to run 4. 1, 2, 3, 4. And right there is where I'm going to make my dot.
This one is not proportionable.
That's right.
Proportionable.
Proportionable.
Proportional.
Okay, guys, please stop. Give me a thumbs up if you saw what we did there. Does that make sense? Pretty easy, right?
Kind of. Yes.
From this point now, we're going to do step 6, which is repeat this pattern. So from here, I'm going to rise 3. I'm going to run 4. And I'm going to make another dot.
Looks like an M for me.
I'm going to rise 3. I'm going to run 4. And I'm going to make another dot.
Another one.
Oh.
You guys see how all those...
So you go up 3 and then go up.
That's all it is.
Oh, I'm a genius.
You go rise 3, run 4. Rise 3, run 4. It's the same pattern every time.
So we go right.
Yeah, you always run to the right. Except for right now, okay? And I'll explain why. This is where it gets a little confusing, so you really need to be paying attention, okay?
Locked in.
So notice how we only have points on the right side of our line because we're only running to the right. And we start or we begin here on this yellow line. So if we follow this process, we're never going to have any points to the left. We don't want that, okay? So what I'm going to do is I'm going to go back to the beginning, okay? I'm still going to rise 3 and run 4, but I'm going to do the opposite direction. So what's the opposite of up?
Down.
And what's the opposite of right?
Left.
So instead of going 3 up, 4 right, you guys listening in the back? I'm going to go 3 down, 4 left. So here I am at the beginning. Don't do anything on yours. Just look at me real quick.
Okay.
Or not me, but look at this real quick. I'm going to go down 3 and left 1, 2, 3, 4. Make a dot. See how that dot's still in line with all my other points? Okay?
Oh yeah, I missed.
I'm going to go down 3, left 4. That's why I said just watch first. Make another point. Down 3, left 4. Make another point. Are all of those points in line with each other?
Yeah.
Yeah, it looks nice and symmetrical, right?
But it's not proportional.
What you going down? Down 3, left 4.
That's right. Whatever, this is why we want to write the directions here. Up and right. Because now you're going to do the opposite. Okay? Down and left. Right? If our slope was negative and we went down first, then when we reverse it, we'd go up and left. Okay? It takes a little bit of practice. That's why we're going to get practice.
Where did my ruler go?
Real quick, take your ruler, connect all those points together to make a nice straight line.
Oh yeah, I missed.
What'd you do?
I had gone up 4 on accident, and then I just.
Oh, I see. That's all right. As long as you connect the right points with your ruler, you should be okay. And we're gonna get more practice right now, so you have a chance to redeem yourself a little bit. You guys think that's easier than doing the table and plugging in and solving? Easier? Okay.
Very much.
Let's see how easy it is.
Not another one.
Pass those out. I won't get tired this time.
Go ahead and glue this second piece in once you get it.
Well, yes it is.
Hold on one second.
Why are you looking at this?
You gotta wait a second after this. There's too many people out. I'll keep it on.
Stop snatching. I didn't growl at my mouth. Was just gotta be this big. I was taking my wings. My point was. I don't know if sound like
All right, let's go ahead and take a look at example B. All right. So with my slope highlighter, who can tell me what's my slope for this line?
Your slope is 2.
2. How do we know that it's 2? It's right in front of the X. Gentlemen in the back. Hands. So my M is 2. Okay, what was step 2 again?
Step 2 was turn M into a fraction. It's not already.
Is 2 already a fraction?
No.
So what can we put it under it to make it a
1.
fraction? 1.
I'm so smart.
Do not forget to do that, okay?
So we always have to make a fraction.
Yes, right? Because we need a rise and we need a run. Even if that run is just 1, we still need to know that that's my run.
And then put like a 1 under it, even if it's a 1.
Yeah. If I have a slope of 1, I still want to do 1 over
That
1.
doesn't make sense because 1 over 1 is just 1.
Yes, but if we write it as a fraction, that gives me 2 directions, right? It gives me a rise and a run.
Okay.
Yeah. 2 over 1 is just 2, right? So we're not changing the slope. We're presenting it in a way where I can see 2 directions, a rise and a run. Would you be able to come back in like 5 minutes?
Either that, but if I'm not, I can just come on.
Okay, perfect. Thank you. Because I want to make sure we all got this, okay? So for 2, what direction or... Wait a minute. I'm going out of order.
Mm-hmm. You're supposed to do that B first.
That's right. We got to identify the B. You got me. What is my B in this problem? Thank you, Sophie. -3, not just 3. -3. All right. Here you go. So -3, that's where we're going to begin. That's why it's called the B. Okay, we're going to begin at -3. All right. So if I'm looking, let's go ahead and highlight our y-axis. I'm all thrown off now. Everybody highlight their y-axis? Yeah? Is -3 going to be above the origin or below the origin? Below, because it's negative. So I'm going to go down to -3, and I make my beginning dot right there. You see that, Zach? You're holding your paper. It should be on your desk and writing. Okay?
Sorry.
It's all right.
Thank you.
It's okay. All right, now we're going to take care of our slope. So my numerator, is that my rise or is that my run?
That's your run.
That's my rise. Now, because my 2 is positive, what direction am I rising? Up.
If it's
My denominator, 1, what does that represent? Your run, okay? What direction am I going to run?
down, right.
To the right. We always run to the right,
Unless you have to, like,
okay? Unless we get to the end where we reverse, exactly.
reverse.
So we got our beginning point. Yeah, give me a thumbs up if you got your beginning point graphed on there. Okay, only half of us. Okay. There's my beginning point. From that beginning point, I'm going to rise 2, run 1, and make a point. I'm going to zoom in super close. Yeah, Jawad?
I did the what again?
We turned our slope into a fraction. So because it was just 2, right? Anytime we have a whole number slope, we put it over 1. Yeah? So if this said 7x, right, it would be 7 over 1. If it said negative 10 over 1. You're welcome. So I'm going to zoom in because I know the graph is kind of small. We began right here. What's that? This point or this point? The red point? It's on negative 3. Because my b is negative 3. Yeah, we begin at negative 3. You see what I mean? Yeah. So that's our starting point, right? All right? So we rose 2, ran 1. I'm going to keep going. I'm going to rise 2, run 1, make a point. Rise 2, run 1, make a point. And we're going to follow that pattern as far as we can go.
I already did it.
Okay, and that's as far as we can go right there.
Come do it then. No, you didn't.
Okay, guys. Please stop whistling. Okay, so we've got the right side of our graph filled out. Yeah. Great question. So the reason why we keep going up is because the more points we have to connect, the more accurate our line is going to be. Okay? Ooh, almost knocked it over. For example, right, if I had just these 2 points, right, and I went to make a line, like this part of the line, because there's no points to connect it through, it might be a little bit wonky. It might be a little off. But if I have a bunch of points to line up, then I know I'm connecting through all of them. And it just makes it more accurate, okay?
But why would it matter if it's wonky? You still got the same answer, right? With the 2 points.
Because you want your answer to be as accurate as possible, okay?
But would it change the answer at all with just 2 points? Rather than 1, 2, 3, 4, 5?
So, I see what you're saying. Technically, as long as you have your B and one other point after the slope, technically it is right? But like if you were an engineer and you're making blueprints for a house, like do you want those measurements to be precise or do you want them to be kind of good enough? You want them to be precise, right? So it's the same idea here, right? I know it seems annoying, but it's just a pattern that we're following and it's just making dots, right? So it shouldn't be too bad. But technically, I mean, in terms of like math definitions, yeah, you only need 2 points to make a line. So technically, you could just do it with 2. I prefer you do it with more.
No, Mr. Coronado.
All right? So, we're not done. That's a great question, though. We filled out the right-hand side. Now we're going to fill out the left-hand side. Focus up. What's okay? What directions am I going to go to fill out my left side? I'm going to go left, and I'm going to go down. Which one am I going to do first, the left or the down?
Left.
We got to go down first, right? Rise over run. Even though we're flipping the directions, we're still doing rise and then run, okay? So I go back to my beginning. Here's how that looks. I go back to my beginning. I'm going to rise now down 2 and left 1. Down 2 and left 1. They should be in line. Look at that. We zoom out. We see all those points are lined up consistently. I'm going to connect that first point to my last point, making sure I'm going through all the ones in the middle. And there I've got a nice, precise 2x minus 3 on my graph. Okay?
Do you have a golden ruler?
I do. Okay? Nope.
What time do we get out?
Not soon enough. What time? Not what time. How are we feeling about this? Are we feeling okay? Okay. Jawad and Angelina feel good. How about everyone else? Are we feeling okay?
Amazing.
Okay. Gianni, yeah. Okay. Okay. Now, example C is a little bit different. Let's take a look. What's my M in example C?
-5/3.
Perfect. -5/3. Thank you, Alicio. -5/3. Now, because it's negative, I want to put my negative in the top. So, -5/3. Even though my negative's out in the middle, I want to bring it up to the top. Okay? So, my -5 is my rise. What direction am I going to rise for -5? Down. Good. Now we're rising down because our slope is negative. My denominator, I'm going to run. What direction am I going to run?
Left, right. Go like that.
To the right. We always run to the right until we get to the end. Diego? There's someone waiting right now. It's full. And then if we have time, we can. So we're going down and right now. What is my B value here?
0.
Nothing. So it's 0, right? I don't see a B value over there. So my B value must be 0. That's where we're going to begin. I'm going to highlight my y-axis. Just like that. Where is 0 on my y-axis? At the origin. Good. So we're going to begin in the very center. What type of relationship is this? Proportional, because it clearly is going to go through the origin. Okay? Everybody with me so far? Am I going too fast? No, you're with me? Okay. So from this beginning point, I'm going to rise down 5, and I'm going to run to the right 3. Okay, so here I am at the beginning point. I'm going to go down 5, right 3. Down 5, right 3, make a point. I'm going to repeat that. Down 5, right 3, make a point.
Oh no.
We should see that now our line is sloping downhill, which is what we want because it's negative. Yeah.
I literally went actually down. I messed up.
Well, like you drew a line down?
Yeah.
That's fine.
Yeah.
That's totally fine.
Oh.
So now go to the right 3. So it looks like you only went down 4. You got to go down to the next one. And then go right 3. 1, 2, 3. Make a dot right there. Okay, so now you know you're going to connect this point with that point with your ruler. But we're going to keep going. So we're going to go down 5 again, right 3 again. Make another point. So we're just going to continue, Zach. You okay? Okay. All right, I'm going to go back to my beginning. I'm going to reverse. What's the opposite of going down 5? Up 5. What's the opposite of going right 3? Left 3. So now I'm going to go up 5, left 3. From the beginning, up 5, left to 3. Boom. I'm going to check and make sure all my points are in line. And they are, so I know I did it right. I'm going to do it again. Up 5, left 3. Make another point. That's all I can do. That's all I can fit on this graph. So I'm going to take my ruler, connect all 5 of those points together, and get a nice straight line. This is a straight line through the origin, which makes it what type of relationship again?
A proportional.
Proportional. Go ahead and write proportional somewhere on there. What would that make the first 2 examples? What type of relationships would those be? Non-proportional. That's right, Anila. Non-proportional.
Can I put this on your desk?
I'll take it.
Someone under Leo.
Yeah, it's for Rich.